Okay, since we're new to this, we need to first, before I go into the packet, determine how to solve absolute value equations, okay, and inequalities on the back side. So whenever we see an absolute value, we need to make a table on the other side. And within the absolute value, I have x plus 6, x plus 4. That's your absolute value function. Now, you replace your absolute value function with d. And if d then is isolated, well, then you now have the number that you're going to set on each side, okay? So you're going to put equals 6 and equals negative 6. And then you find your two solutions. So on the x side, we just have a plus operation, so we just minus 4. And then x can equal 2. Then on the other side, just a plus, so I subtract 4. Negative 6 minus 4 is negative 10. Okay, next problem. Do not do the rainbows. You cannot do that. You have 4 times, but you can't do the rainbows. It's not a parentheses. The absolute value of the expression 2x minus 3, and then after the absolute value, we have minus 1 equals 11. Okay, so within the absolute value function, we have the expression 2x minus 3. So I write that on each side. Then I replace my absolute value function with d. But it's going to be 4 times d minus 1 equals 11 this time. Okay, now I need to solve for d, because unlike here where d was by itself, it's not here. I mean, d has operations at times 4 and minus 1. Okay, so I like to highlight the times. I have to take out the negative 1 by adding 1, and that takes us to 12. So 4 times d is equal to 12. Then I do the opposite of times, which is to divide. And d is equal to 3. So the absolute value is equal to 3. So to have an absolute value of 3, you could be at 3 or negative 3. Now you can solve. So x has 2 operations on that side. It's got times 2 and minus 3. Okay. Take out your negative 3 by adding 3, and that would take you to 6. So 2 times x is equal to 6. Then I divide each side by 2, and 6 divided by 2 takes us to 3. Okay, then over here you got times and minus, so plus negative. So you take out your negative 3 by adding 3. Now negative 3 plus a 3 is 0. So I divide each side by 2. And x equals 0. So those are your two solutions, 3 and 0. Okay, now on the other side, they're inequalities instead of equations, meaning they don't say equals. They say less than here, greater than here. But we kind of deal with them the same way. We just have to graph them at the end. So within the absolute value function, you have the expression x plus 3. Then, just like on the last side, we replace our absolute value with d. Now d is not going to have any operations with it because there's no times number, there's nothing being added after the absolute value, it's just d with the less than symbol and 5. So I go 5, but it's not equals. You have to use the given symbol on the 5, and then when you do the negative 5, you flip the symbol. Now we solve. We have a plus 3, so I just need to minus 3. There's no multiplying or dividing I need to do, so that sign will stay the same. We minus 3, because I'm not even going to divide at all, much less by a negative. So I have x, 5 minus 3 is 2. Same thing here. When you add or subtract, the sign does not flip, it just lines up. X, negative 5 minus 3 is negative 8. Now they need to be transferred to a graph when we have the inequality symbols. 0, you have 2 on one side, and then you have negative 8 on the other. So you circle both, you don't fill in either. Look at the board, it's eating the number on 2, so eating the numbers this way, and it's eating the x on the negative 8. So what happens is they combine, and when they combine I put x, negative 8 on one side, 2 on the other. The highest number has to be eaten, and then the x gets eaten. Okay, so x can be all numbers between those. Okay, and then the last one, we have the absolute value of x minus 4 greater than or equal to 2. Okay, So anytime I see that absolute value, I'm setting up a table. So inside you got x minus 4. And then you have, replace the whole absolute value function with d. Now there's no number multiplying outside. There's no number being added or subtracting outside. I just got my symbol. And on this side I just have d by itself. And this side I have 2. Okay, so 2 is the number I'm using, but I do the given inequality on one side. And then when I do the negative 2 on the other side, the inequality flips. Okay. Okay, now, that's a minus plus negative. So again, we will keep the sign the same, okay? Because I don't even need to divide at all, much less by a negative. So plus 4, plus 4. So we have x, 2 plus 4 is 6. Same thing here. We don't even have the multiplication or division operation to the variable. So the sign will stay the same. And I just go add 4, okay? Negative 2 plus 4 is 2. So 6 and 2. So 0, I've got 6 and 2, both on that side. Both circles would be filled in. Now with the x and the 6, it's eating the x, so that would be this way. And with the x and the 2, it's eating the value of 2, so that would be this way. So then when they're separate like that, I just label them separately. So I just write that on one and that on the other. Okay. Now, last lesson in this unit. We will need to review for this test quite a lot. We won't be even taking it this week. Okay, story problems, but they're not that hard. A manufacturer is cutting metal into rectangles that are 20 inches long by 35.25 inches wide. Each metal's length and width must be within 0.25 inches of the desired size. Write inequalities that describe the acceptable range for the length and the width. Circle that word range. Okay. This is how you set up a range to be found. You make a number line for both the length and the width. Okay. Then you make 3 tick marks on the number line. There's 3 values that are going to be there. 0 is not going to be in the middle. You can't have a length of 0. Now, here's what I do to find the range. What's the length supposed to be? Long means length, okay? If you want to put long right there, that's fine. Width, another word for width is wide, okay? Okay, so it's supposed to be 20 inches long, so I put a 20 there. Now, width. Wide means width. That's supposed to be 35.25. Okay. Now, here's the thing. That's what it's supposed to be, but you're allowed to go over it by a certain amount or under it by a certain amount when you cut it. Okay. It's okay to go over it or under it. Well, what's the most I can go over and what's the least I can go over? Well, here's how we figure that out. You take your 20, okay, and you put a plus on top of a minus, okay, plus minus. You're going to add and subtract the same number, and the number is going to be what's known as the variation, 0.25. See, I wrote that in the corner. That means you're allowed to go up by 0.25 or down by 0.25, so I put 0.25. So then first I add, okay, 20.25, and that's your maximum. Now, you take the calculator, and now you subtract. You minus 0.25, and that's 19.75. Okay? Now, you take out the 20. You don't need that anymore. You'll just X it out, and you're going to put circles. You do fill them in on story problems because you can be equal to those amounts. Okay? And then you connect the lines. Now I want the graph label. Use L for length. You put 20.25 over here, 19.75 here. Then you eat the highest number, and then you eat the L. You never eat the lowest number because that's as low as it gets, and that's what you do. Now on the width, we do the same thing. We take our 35.25 and we add or subtract the same number to it. We add or subtract the variation. Okay, 0.25 variation for both. That means you add and subtract that for both. So on one side, you take 35.25, and then you add 0.25 because you're going to the right. That's 35.5, put 50.50. And then I take the 35.25 and I subtract 0.25, and I get 35 even, okay? So it's supposed to be that, but it's okay if we're that high, or it's okay if we're that low. Then you ditch that, don't need it. And then you use W now for your variable. It stands for width. So the width, the lowest it could be is 35. The highest it could be is 35.50. So you eat the highest, but then you eat the variable. Okay. Okay, next problem. The ideal circumference of a women's basketball is 28.75 inches. The actual circumference may vary from the ideal amount by at most 0.25 inches. Write an inequality that describes the range. There's that word range of the circumference. So for range, I make a number line. Now, what's the circumference supposed to be? It's supposed to be 28.75 inches. But I can go over it by a certain amount and under it by a certain amount. Plus minus, that means plus minus. And the variation is 0.25. So, to find the maximum, we take 28.75 and add 0.25, and that's 29 even, 29 whole inches. And to find the less, we take 28.75 and we subtract 0.25, and that's 28.5. Circles, circles, then you ditch that and connect them. So C for circumference, the highest it could be is 29, the lowest it could be is 28.5. So you eat the highest, and then you eat the variable. Okay. Okay, next one. The ideal length of a horse fence is 300 feet. The length must be within 5 feet of the ideal amount. The ideal width is 450 feet. The width must be within 10 feet of the ideal amount. Write inequalities for the range for both the length and the width. Okay. So we have a length to find a range for and a width to find a range for. Okay, length. What is the length supposed to be? Well, it says the length is supposed to be 300. What's the width supposed to be? The width is supposed to be 450. Okay. Now, length. Remember, you add and subtract to the 300. Now, that's what a variation is. So for the length, the variation is 5 feet. So 300 plus 5 is 305. 300 minus 5 is 295. So we circle fill, take out the 300, don't need that, and you connect. Okay. So we put L. The highest it can be is 305. The lowest length can be is 295. Then we eat the 305 and we eat the 295. Now your width, you take your 450 and you add and subtract. Okay. Now it's 10 feet for the width, so it'd be plus 10 and minus 10. It says it up in the corner. So you're allowed to go 10 over 460 and then 10 under. 450 minus 10 is 440. So you fill them and then connect them. So you got W, and you have 440 on this side, 460 on the other side. You eat the 460, then you eat the W. Okay. That's all you do. Really, it's not hard math. Okay, last problem. The ideal length of a certain length of a nail is 20 millimeters. The actual length must be within 0.4 millimeters of the desired size. Write an inequality that describes a range of the acceptable lengths of the nails. So just one. What's the length supposed to be? It's supposed to be 20 millimeters. It's supposed to be that, but I can go over it and under it by the variation amount, which is 0.4. So 20 plus 0.4 is 20.4, and then 20 minus 0.4 is 19.6. So I circle, fill them, okay. Take the 20 out, you don't need that anymore. And then you write L, and the lowest it can be is 19.6, the highest it can be is 20.4. You eat the 20.4, then you eat the L, okay.